So what we're going to have here is this m is going to go to everything on the inside, and it's going to be multiplied. Okay? So once we do that, you're going to have a to the m power over b to the m power. Okay? And then you would use your quotient rules from there. All right? If you have negatives, use your negative rule. If you have like bases, okay, you use your product rule. It all just depends on how all this works out. Okay? So it's the same as our power rule. Your exponent goes to everything on the inside. All right? And once you get that worked out, then you use your exponent rules to finish that out. Okay? So we're going to look at a couple of examples here. Let's say I have 2 to the 5th over 2, and all that is raised to the 3rd power. So first thing, I will distribute my exponent first. Okay, that'll get rid of any type of concerns you would have with negative exponents. All right, so I will take this 3 here, so that would give me 2 to the 5 times 3 over, distribute your 3 down here, your 2. Remember, if there's no exponent, there's automatically an exponent of 1. Okay, so that's going to be 2 to the 1 times 3. And when you work that out, you'll get 2 to the 15th over 2 to the 3rd. Okay? Now my question here is this complete as it is? Yes or no? Do I have similar bases? Yes. Okay? Which means we can keep working. So with my similar bases, okay, notice I have a 2 and a 2. So with similar bases and my quotient rule, I know that my 2 comes over. All right? And what do I do with my exponents with the quotient rule? Do we add or subtract? Remember, you guys said to divide means to make things smaller. Like if you have a pizza and you divide it amongst your classmates, that pizza gets smaller, right? Okay, so we're going to subtract. So we're going to have 2 to the 15 minus 3. And what is 15 minus 3? 12. So your final answer will be 2 to the 12th power. Okay? And you would just leave it as that. Most of the time, you're just leaving exponential form. It won't ask you to evaluate. But now on your multiple choice answers, if you don't have this as an answer, I will plug that in and work it out. Okay? And it'll give you that answer, whatever it is you're looking for. Okay? All right, let's look at another one here. Let's say I have 9 z to the 6th over 7z, and all of that raised to the 2nd power. So just like our power to a power rule, this 2 is being distributed everything inside of here. Okay, so it goes to my 9, it's going to go to my z to the 6th, it's going to go to my 7, and my z to the 1st. So this will just be 9 squared, z to the 6 times 2, over 7 squared, z, and there's just a 1 there, so it's going to be z squared. Okay, now you don't have to do this. I just do this to show you guys it's multiplication. Okay, for some people that just kind of helps them and it clicks for them. All right, so if you feel like you need to do this extra step, do it. Okay, but if you don't, it's also fine too. So that simplified will be 9 squared z to the 12th over 7 squared z squared. Okay. Now, looking at this problem is not done. Some of you guys would stop here. Why is this not done? What do I have here that I can simplify? Look at my bases. Do I have similar bases anywhere? Yes. Which is the z. Okay. I have a z here and a z here. Well, if I have one of the numerator and one of the denominator, what rule am I going to use here? Subtract them. I'm going to use my quotient rule. Okay. So my 9 squared and my 7 squared will stay. So I have 9 squared, 7 squared. Okay. And I'm going to have z to the 12 minus 2. We're subtracting because that's my quotient rule. And once I simplify that, I'll get 9 squared z to the 10th over 7 squared. And that'll be my final answer. So we're just taking our exponent to everything on the inside, the numerator and the denominator. Comes out over here. Then we're looking for similar bases, okay? These are rules, all right? Whatever rules that might be that we might have out there. All right, let's look at one more. Let's say we have dk over 2 d to the 4th k to the 6th, all of that raised to the 3rd power. Now this is a problem that some of you guys might shut down because there's a lot going on. Okay, piece it together. Do it one piece at a time. All right. I preach to my students all the time: make math your own. However you understand it, make it your own. Okay. So if you're somebody that can take this and do it in one step and get here, that's great. Okay, that's fine. If you're a student that needs to go through all these steps to get here, that's fine too. Because at the end of the day, guess what? You both got the same answer. You're both right. You just did it differently. Is that okay? Yeah. All right. Social media. Is everybody's social media page here exactly the same? Same picture, same everything? No, they're different. Okay. Same thing with math. Math, do it your way. However you understand it, do it that way. Okay. So we do this one piece at a time. Multiply this here, we get d to the 3rd power. You get k to the 3rd power. Look at the bottom. This 3 is going to go to this 2. So it's 2 to the 3rd. D to the 4 times 3. And k to the 6 times 3. And when you simplify that, d to the 3rd, k to the 3rd, 2 to the 3rd, d to the 12th, k to the 18th. Right? Now this problem is a little different than example 2. Here's why. Okay. Notice in example 2, look at my z's. The z in the numerator, okay, its exponent was larger than the z in the denominator, which made subtracting easy. We just kept it in the numerator, right? Okay. Now, with this problem, I'm going to keep my variables in the denominator because that's where the larger number is. All right, and I'm going to show you why. Okay, we're going to do this one way, and I'm going to do it another way. So we know that we have like bases. I have a D here and a D here. Okay, and then I'll do my K's in a different color. And then I have a K and a K, and we're going to subtract. Okay, So I would have d to the 3 minus 12 k to the 3 minus 18, and all of that is going to be over whatever's left. And what's left is 2 to the third. Okay? Now, what's 3 minus 12? It's not 9. 12 minus 3 is 9.
Oh.
3 minus 12.
Oh.
Is what? Negative 9. So d to the negative 9. Okay. What's 3 minus 18? Negative 15. K to the negative 15. And all that is still over 2 to the third. Is this problem complete yet? No, why not? We got negatives. How do I make those negatives a positive? We flip it. So I still have one more step here. If I flip my d to the negative 9 and k to the negative 15, if there's nothing left in the top, what number goes there? A 1. So it's going to be 1 over 2 cubed d to the 9th k to the 15th. Okay, that's one way to do it. All right. And you can do it this way, and that's fine. The only thing is, it gives you this extra step. Now, what I'm going to show you is I'm going to subtract whichever exponent has the, or not exponent, whichever variable has a larger exponent, I'm going to leave it in the numerator denominator and subtract the other one. Okay? So, what I mean by that is, okay, if you look up here, d to the 12th in the denominator, okay, 12 is bigger than 3. So I'm going to have d to the 12 minus 3, okay? K, 18 is bigger than 3. I'm going to leave the k in the denominator and do 18 minus 3, all right? And then I bring the rest. 2 to the third, I know this up here will be a 1. So once I subtract, I get 1 over 2 to the third, d to the 9th, k to the 15th. Same exact answer, two different ways to look at that. The only difference in the bottom and the top is the bottom way I avoided the negative exponent. Okay? And you avoided the mistake that Brian made in saying that 3 minus 12 was 9, because a lot of you might have had d to the 9th, k to the 15th over 2 to the third, and you would have got it wrong. And you'd have been completely confused, like, Mr. Reed, I did that right. I know I did that right. Why is that wrong? Okay? You got to pay attention to your 3 minus 12 is the negative, and then 3 minus 18, which would be a negative. Okay? So the only difference in this method and this method is we avoid these negative exponents. Okay? So my advice would be whichever variable has the larger exponent, subtract it from that side of the fraction. Okay? So if your larger exponent is at the bottom, I would do 12 minus 3 in the denominator. Okay? Or vice versa, like we did up here. Your 12 was larger in the numerator, so I just subtracted it in the numerator. Okay? It helps you avoid those negative exponents. Now, if that's really confusing and you want to do it like this, that's fine. Again, make math your own. However it is that you understand it, make math your own.